This is a lesson for 4-6, which is interpreting graphs. All right, first of all, the word interpreting. All right, the word interpreting just means what does the graph mean? All right, what does the graph mean? A lot of times on your 8th grade state test, you have these as multiple choice questions, and we'll talk more about that as we keep on going throughout the lesson. But you're really looking at a graph today and figuring out what the graph is saying. And you might have to answer some questions from the graph. So when you take a look at graphs in general, all right, if it is a super steep line like this, first of all, you always look at the graph going from left to right, just like you read a sentence, all right? So if it is a steep line, that indicates a high rate of change. That means the speed is going up quickly. The more straight up and down your line is, the more quickly something is going up. Now that might mean also like the height of something. The height of something might be going up. Like if you were walking upstairs or climbing a mountain or maybe a plane taking off or something like that. The a more gentle line, notice that this line is a little bit flatter than the other one. All right, if the line is a little bit flatter, that indicates a slower rate of change, but it's still going up, it's still increasing. If something is completely flat, notice this one goes straight across, that indicates that something is not changing at all, and it might have stopped moving altogether. A downhill line, all right? If our line is going down, that means that it is decreasing. Again, it might be more flatter, so it's decreasing slower, or it might go more steeper, which it would indicate that it's going down quicker. A curved line would represent that something is not staying the same. It's increasing and then decreasing and then increasing and then decreasing. So it might be going up and down, up and down, up and down. Maybe it's the amount of water in a glass. If you keep on dumping stuff out and then refilling it, dumping out and then refilling it, it might be something like that. Or something like if you were maybe running or walking, maybe you're walking and then running and then walking and then running. So you're going quicker and then faster, quicker and then slower, quicker and then slower, things like that. Let's take a look at this one. Now, this is a very sciencey type question as well. What we're looking at in this graph is the temperature during a 24-hour period of time. So notice that we are starting off this graph at 6 p.m. and going to 6 p.m. So we're looking at the temperature outside over a 24-hour period of time. Notice that our temperature is going down and then it's going up. And then right about at 6 o'clock, it starts going down again. So a sciencey type question or a math type question might ask, at what time of day, according to the graph, we're just looking at the graph, at what time of day, according to the graph, is the temperature the lowest? At what time of day is the temperature the lowest? Well, what you would have to look at is, where is my graph the lowest? All right. My graph looks like it's the lowest right here. If I draw a straight line down from there, it's just slightly after 6 a.m. All right, according to my graph. Now, again, on your state test, these might be multiple choice questions, so you just have to pick out the most appropriate answer, all right, based on what they give you. Take a look at where, and I want you to think about where, from what time to what time is our temperature decreasing? From what time to what time is our temperature decreasing? Remember that decreasing means going down. So my temperature is decreasing from 6 p.m. down, 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 down to approximately that 6 a.m. spot. So from 6 p.m. to 6 a.m., the temperature is going down. Now, a more sciencey type question might ask you, why? Why is the temperature going down from 6 p.m. to 6 a.m.? Well, think about what happens outside from 6 p.m. to 6 a.m. What does the sun do? The sun goes down. All right. The sun disappears. When that sun disappears, the temperature most often cools down. All right. So that's why the temperature is going down. The sun rises, and then look at what happens to our temperature. Our temperature goes up, 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 up. Think about the summertime. When is that hottest time of the day? That hottest time of the day after the sun has been up for a long time is normally right around that 4 or 5 p.m. type time. That's normally the hottest time during the day, right? Because the sun has been out, it's warmed up everything. And then all of a sudden it gets to be that 5 or 6 o'clock and the sun starts to set again. So again, our temperature is going to start going down again. They might ask you questions like, around what time to what time is it going up the quickest or increasing the most? According to our graph, it looks like in between here and here, it goes up the most in the shortest period of time. Again, that is the hottest time during the day. Now, take a look at this one. I want you to think at home. All right. I want you to think at home. What would this graph look like? All right. I want you to think at home what this graph would look like. So draw the person's height from the time that they're born until the time that they are about 20 years old. Just on a piece of paper at home right now, just sketch what you think that this would look like, because we're going to go over some possible answers. So notice that we have from the time that they're born until the time that they're 20 years old and what their height would look like. All right, what their height would look like. Just think about what that graph would look like for a second. So let's go over some typical wrong answers. Now, on your math state test, this would most likely be a multiple choice question. They would give you 4 different graphs, and you would have to pick out the correct answer. So let's talk about some wrong answers first. What this one would be a wrong answer. All right, I'm trying to draw as straight of a line as possible. All right, this would be a wrong answer. Now, why would this be a wrong answer? This would be a wrong answer because do you grow the same exact amount? Imagine that this is a straight line. Would you grow the same exact amount every single year from the time that you are born until the time that you are 20? No, you wouldn't. All right. You don't grow the same exact amount. So it would not be a perfectly straight line. All right. Would the line be going up? Yes, it would be. But would it be the same exact amount each time? No. All right. Take a look at this one. Let's think about this blue line for a second. Imagine that line goes straight across. It's hard for me to draw a straight line. Would a person be born? Let's say this is approximately where 4 feet would be. Would a person be born at 4 feet tall and remain 4 feet tall their whole entire life? No, that doesn't make any sense. All right, that's silly. Think about without being graphic, think about a 4 foot tall person being born. Think about a 4 foot person coming out of the woman's body. That's a little scary. All right, that's a little scary. So obviously,
this is my example of a graph.
Yeah, obviously that blue line would not make any sense.
Yeah, this is an example.
Think about this orange one. All right, think about this orange graph. Would this orange graph make any sense? Absolutely not. Think about, let's say that this is where 6 foot tall is. Would a person be born 6 feet tall and constantly shrink their whole entire life until they end up, let's say that this is where 1 foot is, that they would end up with 1 foot tall? No, that doesn't make any sense. All right. You're not going to be born 6 feet tall. All right. Think about that coming out of a woman. All right. That's not going to happen. And then shrinking their whole entire life and end up being really, really tiny. All right. Only a couple inches tall. All right. That's not going to make any sense at all. So all of these are wrong answers so far. All right. Let's think about this next one. Let's think about this green one for a second. All right. Watch what I'm going to do with this green one. Would this green one make any sense at all? No, you're not being born and then being 6 foot tall when you're like 6 years old, and then shrinking down to about 1 foot tall when you're 10 or 11 years old, shooting back up at 15 years old and being 6 foot tall, and ending up at 1 foot tall when you're 20 years old. Think about the amount of clothes that you would go through if you were growing from 1 foot to 6 foot to 1 foot to 6 foot to 1 foot to 6 foot. That'd just be crazy. All right. So all of these so far are wrong answers. All right. But would they list these as multiple choice answers? Sure. All right. So let's take a look at the next one. Now, this one, born, grow, 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 grow. Maybe you don't grow the same amount. Maybe you have a little growth spurt when you are turning a teenager, so you grow a lot, and then you eventually level off. Would that purple one be correct? No. All right. The purple one's closer to being correct, but the purple one is not correct yet. All right. Now, this part of the graph is correct. All right. This part of the graph that I just circled there, that part is correct. Most people stop growing around that 16, 17, 18 years old. All right. Most people stop growing. Do some people still grow a little tiny bit when they're 16, 17, 18, 19, 20 years old? Sure. Some people do, but most people stop growing around that time. Me personally, I've been the same exact height since I've been 16 years old. All right. Since I've been 16, I haven't grown at all. I could still fit into the same clothes from when I was 16. But do other people keep on growing? Sure. All right. Every person's a little bit different based on their genetics. But this is a wrong answer still, this purple one. Why it's a wrong answer? Why it's a wrong answer is because of right here at the beginning. All right.
It starts with 0.
Yeah, without being graphic, all right, without being graphic, when you are born, think about a person being born. When a baby comes out of a woman, there has to be something there. There has to be. Now, normally we don't talk about a baby's height because babies don't walk, all right? Babies don't stand up right away when they're born. Normally we talk about a baby's length when they're born, how long they are, which is the same thing as height if we stood them up. You can't be born as nothing, all right? You can't be born as air, all right? You have to have some sort of length to the baby. Now, when most babies are born, most babies are somewhere in between 12 inches long to maybe 18 inches long. All right. They're born like this big. All right. Little tiny baby. Now, premature babies, if you ever heard of a preemie baby, some babies are only born maybe a couple inches long. All right. If you're like
The size of a baby doll.
right. If you're like 2 or 3 or 4 months born premature, all right, you're going to be really, really tiny. All right. But you have to be born still as something. You can't be born as air. All right. So we can't start our graph at 0. All right. I'm going to switch to brown here. We need to be born as something. So I'm going to start my graph right in here. You are growing, 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 growing. All right. Some people, and it's not going to be the same. You're not going to grow the same amount. So it's going to be sort of like a little bit of a wavy line. Think about as you've been growing, some years you grow more than other years, but most people, especially when they get down to this like 12, 13, 14, 15 years old, most people have some sort of growth spurt. All right. When you become a teenager, but then it sort of levels out at the end. All right. It sort of goes straight at the end. Most people don't, once they turn about 18, 16, 17, 18 years old, most people stop growing. So this brown line would be the best answer. Now, every year, some people ask me, do people shrink as they get older? Do people shrink when they get into their 70s, 80s, or 90s years old? Yes, they do. All right. Here's why. A little science health type lesson for you right now. I am not a good drawer. All right. Here's my picture. Think about this as a person's spine. All right. Their spine, their back. All right. In between the layers of their bones, all right, in their spine, there is cartilage. All right. There is cartilage in between the bones. That's like a harder jelly-like substance that allows you to move all around and move forward and backwards and side to side with your spine. All right. Now, as you get older and older and older into your 50s and 60s and 70s and 80s, your spine actually compresses. That cartilage in your spine wears away. All right. So it goes from here to maybe here. All right. So your body does shrink maybe by 1 or 2 inches. All right. As that cartilage wears away, now on some people, the cartilage might wear completely away. And then you have bone rubbing on bone. All right. That bone rubbing on bone is called arthritis. All right. If you ever heard any old people say, oh, my arthritis is really bad in whatever body part, that is bone rubbing on bone. It doesn't have that little layer of cartilage in between. So it's bone rubbing on bone. And that gets very, very painful. All right. Think about a chicken bone scratching against the chicken bone. All right. That's going to go and really, really hurt. All right. So do people shrink a little bit? Yes. Now, if you actually talk to a lot of old people, and I'm going to stand up here for a second, take a look at me. All right. Take a look at me. A lot of people, if you go to a nursing home or something like that, a lot of people are walking around. I'm holding a cane. A lot of people are running, or not running, but walking around being hunched over. All right. Being hunched over. A lot of old people, because they are hunched over and not standing up straight, they're hunched over. A lot of people think that they shrunk by like a foot. Now, did they really shrink by a foot? No. It's just that they're hunched over, so their field of view with their eyes is a lot lower than what it used to be. Now, don't ever do this, but if you took that old person and went and stood them up straight, all right, they would go, oh my God, I grew a foot. Did they really grow a foot? No. All right. It's just that they're used to seeing from being hunched over. All right. So do old people shrink by a foot? No. Do they shrink by maybe a couple inches because their spine gets compressed a little bit?
Yes.
Yes. All right. So anyway, a little science health type lesson for you there. Now, this next example is super, super, super important. All right. So please make sure that you're paying attention. This is a very, very, very typical state test question. What we're talking about here is an 11-minute little walk. All right. A little story. All right. There's a story that goes along with this. So we have time across the bottom and we have distance up along the side. So it's a story about a little boy. All right. The little boy was walking. He walked for 2 minutes. All right. And in that time that he was walking, he covered 2 city blocks. All right. He covered 2 city blocks. So he was taking a nice slow walk. All of a sudden, he ran into a friend. He started talking to that friend. Talk. Notice that my line is going straight across. Why is my line going straight across? Well, because as he stopped, he's not covering any distance. So we're not going to go up with it because he stopped and he's talking. So he's not walking anywhere. But is time ticking by? Yes, it is. He stopped and talked to somebody for 5 minutes. He says goodbye to the friend and he starts walking again. Walk. He walks for 2 blocks in 2 minutes. All of a sudden, out of the middle of nowhere, a dog starts chasing him. All right. He's scared of the dog. So he run. He covers 3 blocks in 1 minute. So notice that we have a steeper line here. All right. Notice that we have a steeper line. That's because he was running. He was going faster than when he was walking. The dog stops chasing him. It turns the other way. And so he stops to rest for a minute. As he stops to rest, he's not covering any distance. So a typical type question might say, for how many total minutes was he stopped? Well, he was stopped for 5 minutes here. All right. He was stopped for 5 minutes here. And then he was stopped for 1 minute here. So how many total minutes was he stopped for? It would be 6. How many total blocks did he cover in his little journey? Well, how many total blocks did he cover? He walked 2, he walked 2, and he ran 3. 2 plus 2 plus 3 would give us 7 total blocks. Those are typical type questions that they love on the state test. Take a look at this one. In this one, we're talking about a restaurant. We're talking about the amount of potatoes consumed. Consumed means to eat, all right? Notice that we have the days of the week at the bottom, and we're measuring in kilograms along the side. Now, 1 kilo is about 2.5 pounds, all right? So that's what we're talking about on the side. What happens, according to our graph, between Wednesday and Thursday? What happens to our graph between Wednesday and Thursday? Well, in between Wednesday and Thursday, what's happening? It is going down. It is decreasing. Now, you have to remember that the words going down and decreasing mean the same exact thing, all right? Increasing and going up mean the same thing as well. How many total kilos of potatoes were consumed in the whole week? Well, take a look at our graph. On Monday, there were 15. On Tuesday, there were 20. On Wednesday, there were 30. On Thursday, there were 10. On Friday, there were 15. Saturday was 25. And Sunday, there was 35. So to find the total, you would have to add up all of those numbers. When you add up all of those numbers for each day of the week, there would be 150 kilos. How many more potatoes were consumed on Wednesday compared to Thursday? Well, on Wednesday, there were 30. On Thursday, there were 10. So how many more? You would have to subtract those two numbers. 30 minus 10 gives you 20. Take a look at the next one. The next one, this chart represents the growth of Mrs. Andrews' son, Landon. All right. Notice that we don't have the height this time. This time we're talking about how much her son weighed. At the bottom, we're going from month 0, so from the time he was born, and our last dot is right here at month 24. So that's 2 years old. So from the time he was born until the time he turned 2, we're looking at how much he weighed. So when was the greatest increase in his weight? Well, notice that this part from month 0 to month 2, he goes up by 4 pounds. From month 2 to month 4, he goes up 3 pounds. From month 4 to 6, he goes up 2 pounds. Here he goes up 2 pounds, 2 pounds. This is up 1, 2, 3 pounds. And this is up 2 pounds. So we're taking a look at how much he went up. Where is the greatest increase? Well, the greatest increase would be right here because he went up 4 pounds. So in between month 0 and 2, he went up the most. When was the least increase in his weight? Now, you have to be careful on this one. Yes, there is a 2 here, a 2 here, a 2 here, and a 2 here, but they are not all the same. If they're asking you when did his weight, when was the least increase in his weight, notice that this is a 2-pound increase over 2 months. This is a 2-pound increase over 3 months. This is a 2-pound increase over 3 months. But this one is a 2-pound increase over 6 months. Well, if you only gain 2 pounds in 6 months compared to 2 pounds in 2 months, this is the smaller actual increase. So in between month 18 and 24. What does the rate of growth do over time? They just want to know, what is this graph doing overall? Is the graph overall increasing, decreasing, or staying the same? Well, the graph overall is increasing over time. One last thing. All right, one last thing. Let's draw one more graph because you are going to have to draw one on your homework. So given the following information, draw the graph, and then there's a question to answer. So notice that this one talks about the miles from home. You always have to pay attention to what is on the side. Sometimes it talks about the total distance. Sometimes it's talking about miles from home or things like that. And then we have minutes across the bottom. Bob traveled 1 mile in 2 minutes. So he's starting off here at 0 because he travels 0 miles in 0 minutes. He's going 1 mile in 2 minutes. So after 2 minutes, he traveled 1 mile. So we would draw like that. From minutes 2 through 5, so from minutes 2 to 5, he is traveling. He is stopped at a friend's house. So is he covering any distance between 2 and 5? No. All right. The distance is staying the same. After 3 more minutes, he was 5 miles from home. So after 3 more minutes, so at minute 8, he was 5 miles from home. Now, this represents the miles from home. So after 3 more minutes, he's going to reach that point. For the last 2 minutes, he stopped to take a picture. So he's not covering any more distance for those last 2 minutes. So the question says, how many total minutes was Bob stopped? Well, he was stopped for 3 minutes right here. He was stopped for 2 minutes right here. So he was stopped for a total of 5 minutes.